recognize intelligence that doesn't think, build, or communicate like we do. It's part science, part philosophy, and part cosmic stand-up routine. And I dare say a tribute to everyone's favorite treat, the humble donut. And hey, folks, if you enjoyed this webinar, please consider joining us at SciCon next June in Buffalo. You can find the registration link in the chat. But please join me all in welcoming a scientist who makes even the mysteries of the universe feel like an inside joke we can all get, Dr. Daniel Whiteson. Welcome, Daniel.
Hello, thank you so much for having me. Such a pleasure to be here. And it's wonderful to meet all of you skeptics. Before I get started, just want to, on a personal note, say that I've been a long time reader, skeptical inquirer, and a fan of CFI. Such an honor to be here and to speak to critical thinkers around the world. My pleasure. So let me share my screen and get started here. Boop, boop, boop.
And I should say, as you get started, Daniel, that if you have questions, folks, go ahead and put them in the question and answer section down below or in the chat, and I'll be curating those, and I'll be sure to ask Daniel your questions when we're done.
Wonderful. And so today I'm here to talk to you about the topic of my new book, Do Aliens Speak Physics? And as skeptics, I'm sure you're used to thinking about aliens and asking hard questions about them. And I hope that today I'll inspire you to ask some new kinds of questions about aliens, what they might be like, and what it might be like when they arrive. And in the book, we consider a few various scenarios for what it might be like when aliens arrive. Of course, the pessimist in you might worry that they're just going to nuke us from space, or they're here to eat us, or even enslave us and send us off to the hydrogen mines. But I'm an optimist, and I hope that if aliens arrive and we know they're real, etc., that we might do something even more amazing, that we might have a respectful exchange of knowledge. Because, if aliens arrive here on Earth, that suggests that they're more advanced than we are, because we certainly can't travel the cosmos. And that might mean that they have developed incredible technology. Maybe they know how to build wormholes, or they know how to build warp drives, or they have incredible, new gizmos that they could share with us. And that would all be really fun. But to me, the most enticing thing about the prospect of advanced aliens arriving on Earth is not the fancy technology, but the science behind it. The reason I got into physics and the reason that I spend my life investigating the nature of matter and space and time and energy is because I'm desperate to know the answers to those questions. I really want to know, what is the universe made out of at its smallest level? Where did it all come from? What's inside a black hole? To me, these are such fundamental questions, and I desperately want the answers. And it's incredible to imagine that there could be somebody out there with the answers. If aliens have been around for millions or billions of years, because the universe has been habitable for a very long time, it's possible that they have answers to these questions. And to imagine that there are people out there who know for a fact how the universe began, or what it's made out of, or what's inside a black hole, are there singularities or are there not? It's incredible to imagine, and it's frustrating to think that we don't have those answers as well. And so, to me, the most exciting thing, the most exciting possibility about aliens arriving is that they could come and share with us those bounties, the benefit of their millions or zillions of years of scientific exploration. Of course, that's assuming that aliens, when they show up, that they will be so generous. Maybe they'll decide they're going to gently guide us through the mysteries, or maybe they'll be stingy about it and not share it with us at all, because they think that the process itself is important, that we need to learn it ourselves. And all of this hinges on the assumption that aliens are doing physics or doing science in the same way that we are. And this is something that's been popularized by many physicists, including, Carl Sagan, my personal hero, who argues that they live in the same universe that we do, and therefore they have to deal with the same laws of physics and chemistry and astronomy as we do. But there's sort of two sides to that argument that I want to pull apart today. On one side is Newton's argument. He said that the laws of physics are universal in the sense that they apply everywhere. So when an apple falls on the earth, that those laws of physics, the laws of gravity that tell you how an apple falls, should also apply to the moon and should also apply to a distant galaxy. And so that's universality in the sense of Newton. He takes the laws of physics that we derive here, we measure here, we come up with here on Earth, and applies them to the cosmos. And already that's a huge leap, right? To say that something we've discovered here on Earth applies elsewhere without ever going there, right? Humanity has never left Earth or its close neighborhood. So, to say that our laws of physics should apply to some distant galaxy on the other side of the universe sounds like hubris, right? But, of course, there's data. We know that it is because we can see it. We can study things very, very far away. So, this extrapolation of the laws of physics from here to there, this is sound. This is something we've tested. This is something we would know if we were wrong about. There's a second step which Carl Sagan is making, and many other folks make as well, which is the subject of my book, which is yes, our laws of physics apply there, but would the denizens of that distant galaxy, would they come up with the same laws of physics? Are we a part of some galactic project where we're all deriving the same ideas? Or is it possible that aliens might come up with their own independent way to describe the universe? Their laws could be universal as well, in the sense that their laws apply all over the universe, but they might clash with ours. They might be different from ours. And I want to remind you that the exercise today is to apply our skepticism. It's very tempting to believe that the laws of physics that we've come up with must be universal because they reveal the truth, and the truth is singular and unique, and therefore it's the only thing everybody around the universe would reveal, right? And that sounds great, and it would be wonderful if that were true, but it's also maybe too tempting to believe it, and we need to really goose our skepticism because, specifically because that idea is very flattering. It puts us at the center of the universe. It says that the human project of physics is a universal project, that our ideas are somehow at the center of intellectual life across the galaxy. And that's exciting, but again, it's very flattering. It's seductive. And so it requires us to take a step back and say, is human physics and math the only way, or is it just the only way that we can imagine it? These are not questions we have data for. The way we can look at a distant galaxy and confirm that the speed of light is the same here as there, we don't have any information about this. And so what we need to do is ask what we actually know and what are the arguments on both sides. We do have a little bit of experience trying to speak to aliens. In the 1800s, von Littrow thought that there might be Martian civilization, technological, advanced, intelligent civilization on Mars, and he tried to communicate with them by digging huge trenches in the Sahara, filling them with kerosene and lighting them on fire, writing mathematical equations, hoping that Martians would see them and go, oh, look, there's intelligent life on Earth. This didn't work out the way von Littrow wanted. But, in this glorious history, there's, of course, the Pioneer Plaque, which I think is a great example and a place to start in understanding, the difficulties in communicating with aliens about science, making that connection. And I'm going to be a little bit gently critical of the Pioneer Plaque, but I also want to acknowledge that I think NASA gave Carl Sagan and Frank Drake 2 weeks to put this together. So it was on a very short timeline. So this is the famous Pioneer Plaque, which went on the Pioneer probe, and there's a version of it also on the Voyager Golden Record. And they did their best here to try to communicate with an unknown extraterrestrial civilization that might receive this one day. And of course, they were smart enough to not just write a bunch of stuff in English, because obviously English is cultural, and not even to write our concepts, our scientific ideas in terms of math, because they knew, of course, that our symbols were also cultural. They did their best to try to develop a notation here that could be universal, that somebody might look at and be able to infer from it what it means. And so let's dig into my favorite corner of this diagram, which is this one. So this is what they wrote on, this is what they put on the top left part of the plaque, and they hoped that this diagram was somehow self-describing. Now imagine if you've never seen this before. And I actually put this in front of a bunch of physics grad students here at UC Irvine who are young enough to have never seen the Pioneer plaque. And I asked them, what do you think this means? And I gave them a whole afternoon and a bunch of donuts, and they had no idea. But if you were somebody who had never seen this before, what might you think it meant? There's lots of different things that it might mean. It might look like glasses to you, or it might look like kids sticking their feet out of spaceships, or it might look like a tadpole, or, this is actually Carl Sagan's effort to define a unit of time, because this diagram on the left is supposed to reflect the hydrogen atom, the proton in the center, the electron moving around it in orbit, and the dot and the line reflect the spin of the electron. And so hydrogen does this spin flip transition where the spins are aligned and then anti-aligned. And this happens very regularly, and so they thought this would be a useful way to define a unit of time. And that's what the dash in between is supposed to mean. So the time it takes hydrogen to go from unaligned to aligned, that's a unit of time. And it's a very cool idea, and it's very earnest and sincere, and it's certainly better than I would have come up with. But it's easy also to identify some cultural choices here, some ways that you might need to know something about humanity, in order to make any progress in understanding this if you're an alien race. I mean, think just for a moment about like this depiction of the hydrogen atom, having a proton in the center and an electron moving around it in a sort of orbit. This is not the way we think about atoms now, right? We think about atoms in terms of probabilities, and electrons don't have locations. They certainly don't have orbits in a sort of a Niels Bohr planetary model. In fact, this is how we thought about atoms for like maybe 10 or 15 years, about 100 years ago. And the reason it works in this description is because it has a lot of cultural resonance for us. It's repeated often in diagrams and all over our culture. But it's not really the way that we think about these things. And so already you can see that there's a lot of cultural arbitrary choices that were made in putting this message together. That in order to have any idea for how to decode it, you really have to know a lot about who was sending it and what these symbols might mean to them. So that's just a warm up, and to remind you that in order to tackle this question of thinking about talking science with aliens, we have to be very careful and very skeptical. We have to look for signs of cultural influences, places where we've made arbitrary choices, and work really hard to think outside the box of just our single example of life here on Earth. And this is a big question, and so it's useful to sort of break it down into pieces. And I'm inspired, of course, by the structure of the Drake equation, which is famous not because it's a big, complicated differential equation like the Schrodinger equation or the Dirac equation, but there is real wisdom in the simplicity of the structure of the Drake equation, because it tells you how many aliens you might be able to get in touch with, but the structure of it is multiplication. And this is important because if any of these terms are zero, then the whole answer is zero. And that's the real wisdom of the Drake equation, in my opinion. That it tells you that everything has to line up. Not only do you have to have lots of stars, you also have to have planets around them. And it doesn't matter how many planets you have if none of them are habitable, or if none of them have life, or if none of those have intelligence or civilizations, right? You need everything to fall into place in order to have a chance to communicate with aliens. And of course, we live in a very exciting time where we've recently learned an answer to this question: F planets. Is it zero? Is it one? And now we know that like 30-ish% of all stars out there have Earth-like planets. It's incredible to go from like almost no information about that to solid measurements with uncertainties that are actually scientific. And it tells us that the number of planets out there is vast. But of course, we don't know any of these other numbers. And so we don't know how many aliens there might be out there in the universe. So, with that in mind, I thought, well, I'm not just interested in there being intelligent civilizations out there. I want to know the answer to the question: how many intelligent civilizations could we talk about physics with? How many civilizations are there that I could enact my fantasy with, of sitting down with their physicists and getting answers to questions like what's inside a black hole, and how do you reconcile quantum mechanics and gravity, and what was at the beginning of the universe, or was there a beginning to the universe, et cetera, et cetera? How many civilizations are there out there that would satisfy me? And so I added a few terms to the Drake equation. Not only do there need to be a bunch of aliens, that's the result of the Drake equation, but also we need to be able to communicate with them. And we need to find the ones that do science the way that we do. And they have to ask similar questions to the questions that we ask. And they have to answer those questions in the same way, be satisfied in the same way by the answers. So that's the structure of the book, and that's the structure of the talk I'll be giving today. And remind you, I'm going to be raising some sort of strange sounding ideas that are very counterintuitive, that your initial reaction might be like, what? No, come on, that's crazy. It sounds like you're smoking too many banana peels. But remember that the universe is under no obligation to be sensible or to run along our intuition. And the history of science, the best moments in that history are moments when our intuition was blown up, when the universe said, "Oh, you thought it worked this way? Turns out it works this other way." And we can only accept that to be prepared for those new ideas if we are open-minded to them, if we're willing to divorce ourselves from our hunches, our intuition, our sense of how the universe should work, and be ready for how the universe actually does work. All right. So I'm going to talk about four topics today. Excuse me. The first is just this basic question of, do aliens even do science? Is it required that aliens, having developed technology, wonder about the universe the same way that we do? Or is it possible that there could be aliens out there that have fancy technology that lets them move around the galaxy in record time without building the same sort of mental mathematical models that we feel is necessary to understand the universe? Then I'll talk about the question of how to communicate with aliens. Is physics something we can use as a bridge to connect with them? How could we possibly decode their symbols? And is it a requirement that they use math to describe their understanding of the universe? Then we'll talk about whether aliens ask the same questions that we do. Do they perceive the same universe out of this huge, chaotic, buzzing universe that we live in? Do they focus on the same things, and are they interested in those same questions? And then finally, the answers, the juicy bit. Is it actually required to have one unique answer to the question of how the universe works? And even if there is, are aliens on the same path that we are? Is it possible to be approaching the truth from different directions? And then finally, are we even smart enough to download it from friendly visitors? Do we have the mental capability? Or is our biology going to limit us from knowing the truth about the universe? So let's start at the beginning with science. Is it a requirement that aliens actually do science? So we're imagining some scenario where aliens arrive, right? We're not communicating with them via messages across interstellar space. They're here, they've shown up. We haven't arrived on their planet. And so automatically, we know that they have some technology that we don't. They've developed the ability to go in reasonable time from star to star, which we certainly have not figured out. And it's tempting to say, well, if they have that technology, then they have to know how it works. And very clearly, they're going to be more advanced than us scientifically, right? But ask yourself the question, is that really necessary? How do we know? Is it a requirement to be scientific and technological? Being scientific means developing a mental model to explain why things happen the way they do, not just being able to do them. And that comes from a desire, a curiosity, which is an emotional thing. Like the reason that I am a particle physicist is because to me, the question of what the universe is made out of is the most important question in the universe. Somebody else is sloshing around a rainforest with wet socks watching spiders jump from tree to tree because to them, that's the most important thing in the universe. And it's wonderful that people disagree about what kind of science they want to do because it means we get to learn all sorts of different things. But again, this comes from an emotional response to the universe to want to understand it. And absolutely, science is an accelerator of technology. Knowing how things work limits the number of things you have to consider. You don't have to blindly stumble through ideas in order to develop new technology. But for most of our history, we've been doing technology without science, right? Think about the way we developed metallurgy. People knew how to make those swords, dip them in water, use ash when you make the steel, cool it this way, hammer it that way, without knowing why, without knowing the condensed matter physics and the nanotechnology that was involved. Now, of course, we do understand why those swords were so sharp and the complex structure and the impurities and the role they play. But back then, they just had a recipe and they developed these techniques through trial and error over a long period of time without knowing why they worked. And you might wonder, like, did they even care? Right? They had this technology, they knew how to make these weapons. Did it matter to them, to earlier humans, why it worked and why it didn't work? For some people, you might think, of course it matters. But for some people, they're curious. Other people, they don't really care. Think about what happens when you go into the kitchen to make a souffle. You follow a recipe. You don't necessarily understand all of the chemistry involved in going from raw ingredients to finished delicious souffle. And some people don't care. They just want to get the souffle, right? They just want to eat it. And the chemistry is beyond them and they just want the recipe. But other people, like, I really want to know what's going on and why the bread rises and why the bread doesn't rise. And so it's an emotional thing, whether you need to know answers to questions or not. And so while it's certainly true that science has accelerated our technology, I don't think you can argue that it's absolutely essential to develop technology. And since aliens could have been out there for millions or billions of years, it's possible that we could meet aliens who have been stumbling blindly through trial and error and having developed incredibly advanced technology after millions of years of this process. And they could show up and they could have warp drives and we could ask them, how does that work? What is quantum gravity? What is space and time? How do you bend it? And they could be like, I don't know what you're talking about. I can show you how to build this thing and how to use it and everything else. Like, well, I don't even know what you mean. Right. So it could be that this project of understanding is a fundamentally human one, and projecting it out to the universe could just be assuming that there's an element of humanity of our culture in aliens. And it goes even further than that because the process of science, we think of it as something humans do that is inevitable, and that we sort of reach some place where, like, now we're doing science and we're going to science forever. But the process of science itself is developing. There's sort of a simple myth about how science came about that, the Greeks just thought about stuff for thousands of years, and then 500 years ago, Galileo and Bacon and folks decided, oh, let's do experiments to see which of these ideas would work. And that there's a kernel of truth to that, but it's more nuanced. The Greeks certainly did experiments. I mean, Eratosthenes measured the curvature of the earth using shadows. Like, that's a measurement, it's an experiment. And people have been doing experiments. And so this idea of empiricism sort of gradually developed over time. And it's not about who gets the credit for it. The point is that the process of science itself has been developing and is still developing. Since we added empiricism as an essential part of science, we also added simulations, right? Simulations are fundamental and essential to the particle physics that I do every single day. Imagine explaining simulations to Galileo, right? What would he think about that? And aliens, when they show up, they might do science. They might not do science at all, or they might do science in some very advanced way we can't even imagine. There could be some elements to their science that make ours feel super primitive, or they could have gone another way and have a completely different fundamental technique for building knowledge about the universe that's barely relatable to ours. Or even just from a cultural point of view, I imagine that when the aliens arrive, I'm going to be out there to visit with them, to talk to them about the universe because I'm a physicist. Who are they gonna send? Do they have physicists? Is that a job that exists in alien society? So you can see that there's lots and lots of cultural influences here in the way we think about just the simple scenario of aliens showing up and wanting to talk about science. So what about the question of communication? Is it possible to talk to aliens about science via interstellar email, right? To send messages to them back and forth. And we already saw from the Pioneer plaque that the challenge here is that anytime you're communicating, you're translating ideas from your mind into a set of symbols, right? We don't know how to go directly from mind to mind. We always go via some symbols. And in this case, right now, I'm turning the ideas in my mind into words and into puffs of air, which then get translated into digital signals and puffs of air back into your ears, which I hope are creating in your mind the ideas that I have in my mind. But that only works because we have agreed on a mapping between the ideas in my mind and these symbols. And that mapping is arbitrary. We could assign any meaning we want to a word. It happens all the time. People come up with all sorts of new words and give them meaning. And if you don't know what the word means and the teenagers have invented one, you might be totally clueless. What does 6-7 mean? Why is everybody saying it, right? You can't always deduce it from the word itself because the symbols are fundamentally arbitrary. You can map ideas to any symbols, and there are no symbols that are universal or self describing. We can't even effectively communicate sometimes between human languages. There are concepts in human languages which just cannot really be translated. Like, I speak Danish, my wife's family is Danish, and I can tell you that what people say about hygge on the internet is not what Danes mean when they say hygge in Denmark. It's just a different kind of thing that's really hard to translate, and there certainly isn't one simple word for it. Another challenge is imagine you get a message from aliens. SETI has found something, and it's very clearly a message from some distant planet. How do you decode it? You don't have any idea what the decoding is. So maybe you just try a bunch of things. You explore, you try. Now, if you're decoding a human message, you're like trying to crack, your enemy's codes in World War II or whatever. You can tell when you have the right answer because it makes sense, right? Oh, very clearly, the text goes from encrypted to clear text, and you can read it. How do you know when you've gotten it right if it's an alien message, right? How do you know if it's just like I got it right, but it's super alien, so I don't understand it, or it's just gibberish because I've chosen the wrong decoding? So a lot of philosophers think that it might actually be impossible. And I'm a big fan of SETI, and I think we should definitely listen to the cosmos for messages, but I'm also pessimistic about the possibility of actually decoding it, which is why in the book I focus on the other scenario of aliens arriving in person, because that gives us a physical context where we can like point at a donut and say what the symbol is, the word. So we can actually have that context in common and we can make those connections. We can associate the symbol with the reality. And if you're optimistic about decoding alien languages, it's a little bit disheartening to look at the history of decoding even human languages, right? We can practice by looking at human languages and say, can we figure these out? Because if we can't figure out human languages, our chances of figuring out alien languages are not high. And we have some examples, right? Like people figure out how to decode hieroglyphics. And it's sort of amazing because hieroglyphics at one time were like, many, many, many people knew what they meant. And then all the people who knew how to read them died. And that knowledge was just lost, right? And of course, the famous story is that we figured it out because we had the Rosetta Stone, right? Which is a cheat sheet which tells us the same thing in 3 different languages. And so there's a couple of messages here. Number one, we're very unlikely to be getting the equivalent of the Rosetta Stone for an alien language, right? It's just like the chances that they send us a cheat sheet seem very small. In addition, even once we had the cheat sheet, the Rosetta Stone, it still took us 20 years to crack hieroglyphics. 20 years when we already had a worked out example. And the reason is that we had made the wrong cultural assumptions about what they meant. People thought, oh, hieroglyphics are pictograms, right? That they're purer than words, that they reflect the symbols, the drawings reflect the ideas. That if there's a bird in the hieroglyphic, it's somehow about birds. And if there's a foot in there, it's somehow about feet. But it's not. It turns out to be another phonetic language. And the symbol for bird reflects a sound you're supposed to make. And that's why it took people 20 years because they made the wrong cultural assumptions. So even when the languages are human, even when you have a lot of cultural information, even when you have a cheat sheet, this is hard. And in some cases, in many cases, it's actually impossible. There are lots of human texts for which there are no living speakers and nobody's cracked it. Etruscan is the most amazing because the Etruscans lived at the same time as the Romans. The Romans wrote about them. We know a lot about the Etruscans. We have many, many examples of their writing, but nobody has cracked it, right? And these are biological humans living fairly recently, right, in Western Europe. How hard should that be? And so I think that's a lesson about how difficult it will be to decode an alien language without their help. And that's why I focus on this question of sharing a physical context. If they're here, what progress can we make? And maybe the most promising thing is to begin with mathematics because a lot of people believe that mathematics is not something that we have created, but it's something we've discovered about the universe, that it exists independently of us. And I was fortunate enough to get to ask a question to Noam Chomsky, who is amazing that he answers all of his emails. And I asked him, I had a conversation with him, and I asked him, how would you propose to begin speaking to aliens? Because the man has thought a lot about the nature of language and how to communicate and the universality of language in particular. And he said arithmetic. He said that it's very likely that aliens will have discovered arithmetic, that 1 + 1 = 2 on alien planets the way it does here, and that from there you can build up all of math, and you can even build up things like Turing machines to express complex recipes and ideas. And so that's Noam Chomsky's advice, is to begin with math. And it's very compelling, right? We see that math is unreasonably effective in describing the universe. As a physics major, I remember learning about quantum mechanics and seeing the calculations where they predict the results of an experiment to 9 decimal places. And then they go and do the experiment and it agrees to 9 decimal places. And I had, like, I'm not a religious person or even a spiritual person, but I had a moment where I got chills and I thought, wow, this is not just a description. This is the source code for the universe, man. This is like how the universe decides what's going to happen. It's amazing. And there's many scenarios like this where we feel like math leads the way and helps us discover things about the universe. One of my favorite examples is Maxwell. Maxwell's the guy who unified all the equations of electricity and magnetism, right? You had Ampere's law and Gauss's law, etc. And he wrote them all down in the same notation and structured them the same way. But he noticed something weird. He noticed that there was a lack of symmetry, that the equations between electricity and magnetism were subtly different. There was a missing piece. And he was like, this would be so much more beautiful mathematically. It would just like click better if we add one more term. And of course, you can't just like add a term, but he proposed that maybe this term would be out there. And they went out and they went out there and they did the experiment and they found it. Displacement current is real. And so the need for mathematical beauty, for mathematical simplicity, led this physicist to discover something about the universe. And that's very powerful. That tells you, like, wow, math really is fundamental. And he was a Scot, and then 100 years later, Peter Higgs, who's not a Scot but was in Scotland, did something similar and discovered that you could bring together not just electricity and magnetism, but also the weak force. But again, there was a missing piece. There was something needed to make them click together, and that was his famous Higgs boson, which he hypothesized 50 years before we discovered it, again, out of a need for mathematical symmetry. And so it's very compelling to say, look, math is part of the universe. It's how the universe runs. It's the engine of the universe. But do we really know that? Or is it possible that math is just like the way that we think about the universe? And so you get to like strange questions like, how do we know that numbers are real? Which sounds like, some weird dude at a bus stop might say, but it's a hard question to know the answer to. And there's this incredible book called Science Without Numbers by a philosopher named Hartree Field. And he makes a really interesting argument. He says that a lot of the calculation that we do in physics, for example, when we think about fields, we talk about how an electron pushes on another electron. How does that work? Well, we say the electron has a field around it, and that field pushes on the other electron. It's the explanation for action at a distance. But is that field like out there? Is it part of the universe, or is it part of our calculation? Is it just like an intermediate step, part of the way through calculating what happens to one electron from another? And he said, well, let's try it. And he developed a theory of gravity that doesn't have any fields. And then he took it another step. He says, actually, we don't need any numbers because what are fields anyway? They're just numbers in space. You just put these numbers everywhere in space, you call it a field. And he said, maybe we don't even need numbers. Maybe the whole idea of a number line where we have these values in place in space in our minds is not necessary. So he developed a theory of gravity without any numbers at all, without a number line, without fields, and it works. Okay, it's not pretty, it's not very useful, it's ugly and clunky, nobody would ever use it, but it makes a very powerful point that mathematics might be a helpful tool in our minds, but it might not be required. It might be very useful, but it might not be necessary. So there's a lot of really interesting stuff to dig into, but I want to get on to the question of what questions aliens might ask about the universe. We ask questions mostly about the things that we see in the universe, but most of the universe that we observe is not the full story about what's out there in the universe, right? The visible matter in the universe is a tiny fraction. Most of the stuff that's out there, the matter in the universe, is something we call dark matter, which we can't see or interact with at all. And so your mental picture of the universe, the room that you're sitting in, and the world and the planet and everything, is built mostly out of the things that you interact with and the things you see. It's not a reflection of reality. It's a reflection of what your mind has told you. It's the model your mind has built to help you survive. And there are lots of other things going on in the universe that you are not aware of. You're not aware of. And so, of course, aliens might have a different set of senses, but we as humans have done something amazing, which is that we've extended our senses. We said, well, obviously there's other kinds of light that are out there that we'd like to be able to see, so let's build infrared cameras and ultraviolet cameras and telescopes out there in space that can see all sorts of stuff. And it's amazing what these telescopes have shown us. But this, which is a picture from the James Webb Space Telescope, this is not actually what the James Webb Space Telescope sees out in space. This is what the James Webb Space Telescope sees. And that's because the JWST sees in the infrared. And the point I'm making is that when we build a new technological eyeball, what we do is we translate the information back into something that we do understand. Right? We can't think in the infrared. We can't see the infrared. We can't experience the infrared. So we frequency shift these images back into our native language, our intuitive sensorium, right? And so it's not just a question of what senses we have and can we extend them technologically. It's a question of can we understand what it's like for another being to have a very different kind of sensorium. If other beings have different senses about the universe, what is it like to be them? What is intuitive for them to explain, and what might we never be able to understand? If somebody has no concept of sound, how are you going to explain to them what music is, for example? Or think about, our attempts to extend our understanding into things that can't be well described by our native intuitive mental language. Things like quantum objects. We have no intuitive language to describe these things, and they behave in a way that can't be captured by anything that is familiar to us. So we say, oh, they are particles, or they're waves, or they're sometimes one or the other. The truth is, and I'll tell you because I'm a quantum mechanic myself, that they're neither particles nor waves. Both of those are rough approximate answers to try to describe something which is fundamentally alien, and we may never truly be able to understand it. And so, because aliens might have different senses than we do, it could be that the ideas they have about the universe might be untranslatable. It might be that the way their minds work have been shaped by their different natural intuitive senses so that their ideas are fundamentally alien. All right, so let's talk about the questions that aliens might ask. We think about the universe in lots of different ways, and we have people who study particles, and we have people who study planets, and people who study galaxies. And this is sort of amazing that we can do science at all these different levels. And at each level, we don't really need to understand what's happening inside. Like you can study galaxies without knowing particle physics, and you can study planets without worrying about those quantum objects. And you can do planetary physics without worrying about, all the little details. And this is something we call emergence in science. And it's amazing that it happens. I mean, think about it in the other direction. Like, we struggle in particle physics to model more than a couple of particles because the calculations get just intractable. So one particle's fine, two particles fine, three particles very, very hard. But somehow, if you zoom out enough and deal with 10 to the 29 particles, like a ball flying across the room, that we can model. So when you zoom out far enough, the details don't seem to matter, and a new set of laws emerge that describe in a fairly simple way things that happen at that scale. So we have these different levels of zoom where we can attack the universe, where simplicity emerges, and it's a miracle, in my opinion. I mean, not in that it's in that it's magic, but in the sense that we don't understand why this happens. I mean, imagine walking one toddler across the street. All right. Two, maybe you could handle it. Three, it's already tricky. Now take 10 to the 29 toddlers across the street and imagine how shocked you would be if they like formed a marching band and walked rigidly in place. That's essentially what's happening when you throw a ball across the room, is that you are avoiding all the little details of all those quantum particles and only having to deal with the bigger picture. So we don't know why this is possible, why the universe isn't just a bunch of chaos that bubbles up from its fundamental bits. We don't know why it's possible to make chicken soup without knowing quantum gravity. All right, for some reason, simple stories emerge from the universe and we can tackle them and do science with them even without knowing what's going on underneath. It's the whole reason why science is possible. But what we don't know, and the philosophers still argue about, is whether this is a feature of the universe that somehow simplicity emerges at various levels, or if it's something human. Maybe we're looking at a big complex thing and we're drawing dotted lines around it because we like to categorize stuff. And those dotted lines are arbitrary and in some sense cultural. Think about how we define like planets, right? This is a big mess. The universe out there, the solar system, is really a big spectrum of stuff from little bits to bigger bits, and we've tried to draw lines around them to define it, and it's a mess because these things are historical and the universe doesn't respect our dotted lines. And so the same thing might be true of the way that we're doing science and the questions that we're asking. And fundamentally, none of the questions we're asking are exact, right? Every time we're doing a bit of science, we're sweeping some details under the rug, which means that none of the stories we're telling about the universe are fundamentally true. Even our particle physics is an approximation. We know that it works, but only within some boundaries. And that means that we can never claim that our theories, no matter how accurate, are the true theories of the universe. They are an approximate description of what we think is happening. Even if you go all the way down to like what we think might be the fundamental scale of the universe, well, it turns out we don't know that there is a fundamental scale to the universe. There's a lot of popular science out there that tells you that we know that the universe is pixelated at the Planck scale, but we don't actually know that. That's just the boundary of where our theories stop working. So finally, this is a question of the answers. One idea is that we could be developing a set of physics, but aliens could be out there finding some other set of physics, some other idea which matches all of the data and perfectly well describes all the experiments, but tells a different story about what's happening in the universe. Philosophers worry a lot about this, that there might be multiple explanations for the same data. that there could be like more than one version of the truth. What would it mean if, we have an incredible theory of physics and aliens show up and they have a very different theory of physics, not just one that like maps from ours to theirs in some sort of renaming scheme, the same theory in different clothing, but is really a fundamentally different conceptual explanation. What does that mean about what's true? And then finally, we got to wonder like, what if we're just not smart enough? What if the aliens show up and they try to explain it to us, and we just don't have the brain power for it? Our brains were not designed to talk to aliens. They're not designed by anybody, but evolution, the conditions under which they have evolved, have not required the ability to deal with arbitrarily complex mathematical concepts. And it could be that the very abilities that we're given, the structures and the power that our brain has, also could impose some limits on what it's capable of doing. There's a popular comment out there I see people make that Gödel's theorem, the incompleteness theorem, tells us that from a limited set of axioms, you can't always describe, there's always something you can't describe. And this might suggest that we can't necessarily understand all of physics. That doesn't actually apply in this scenario because we're not limited to a certain set of axioms. But in the end, it might be that we need assistance from some of our AI. There could be a scenario where aliens show up and we can't understand what they're saying, but maybe our AIs talk to their AIs and make some kind of connection. So the book invites you to ask, like, well, what do we really know about these questions? It's tempting to believe that we're going to be well aligned with aliens on these topics, but we don't know. We certainly don't have data. And so the skeptic in you should ask, well, are there other possible explanations that aren't quite as flattering, that don't put us at the center of the universe? And if you talk to philosophers, they're a lot less confident than physicists are that the way we do physics is the only way you can do physics in the universe. So if you enjoyed that, I encourage you to check out the book. It's called Do Aliens Speak Physics? Here's some nice things that some of my friends said about the book. Thanks very much, and I really look forward to answering any questions.
Okay. Thank you for that. I did read the book, so I enjoyed your presentation and summary of the book. I highly recommend it to Aliens Speak Physics. If you
Thank
guys
you.
out there haven't read it but enjoyed this, highly recommend the book. I'm going to be handing it off to some really smart teenagers after this. So we have two people who asked this James DiPaola and Gregory Terratola.
Hmm.
Both asked about the Andy Weir's Hail Mary project. It speculates on human and alien scientist contact. Gregory writes, I'm intrigued by the idea that aliens may have different physics than we see, but is there any evidence that the speed of light, for example, moves differently anywhere else in the universe? Or is the speed of light a fact on which aliens and we can agree upon? So thank you, Gregory, and thank you, James, for those two similar questions.
Yeah, I'm a big fan of Andy Weir's. Love that book. Looking forward to the movie coming out next year. Randomly, a guy I went to high school with is writing the screenplay for that movie, so really excited to see what he does with that. I'm a big fan of that book, and I don't want to spoil it for anybody. I think Andy did a good job of thinking through how things might be different. And then there are times when, to make the story works, he's got to move things along. Like there's a point where he and the alien are like sharing jokes, and I'm a little bit more skeptical that we'll figure out like alien humor in a few weeks. But to tell a story, sometimes you have to make these sacrifices. But the question was about the speed of light, and it's certainly true that the speed of light is the same here as it is, on Uranus, and as it is in Andromeda, as it is in distant galaxies. And this is something we can definitely verify because the speed of light is deeply connected to lots of processes in physics. And if it were different, we would see things rotating at different speeds. We would see things interacting differently. It would be obvious if the speed of light was very different in other parts of the universe. But I think that's a separate question from, do the aliens have a theoretical framework which includes a number, the speed of light? Do they have the equation E equals mc squared? And you might be tempted to say, well, of course they do, because that's relativity and they're going to discover that. But we know that relativity is not the fundamental theory of the universe. It is flawed. Does not respect quantum mechanics. And so while it's very effective and very powerful and very useful for us, it is an approximate description of the universe under some conditions. And that means that aliens aren't necessarily required to come up with that theory and even have this concept of the speed of light in their relativity, or to observe the same kind of phenomenon. Or imagine aliens who like evolve under some surface ocean, right, with a frozen crust. And so they develop in the dark. And light to them is like, well, the speed of light, speed of what are you even talking about? And so it seems likely that they would understand light because light is pervasive, and there are stars everywhere and an important source of energy. And so I wouldn't guess that most aliens don't know about the speed of light, but I don't think it's necessary for aliens to have this concept, to develop a theory of relativity and measure this same concept that we have.
Hmm. Okay, this is a less lofty question, but a very important one. William Hausman, I'm glad he asked. He said, "Do you do the sketches for your presentation slides yourself?" And
Not at all.
I'm going to hold the title of the book up here. Are you a physicist who likes to draw or an artist whose hobby is physics? Well, we,
Great question. So this book is a collaboration with a friend of mine, Andy Warner. He's a nonfiction cartoonist in Berkeley, and I had an idea to write this book, and I emailed him, and he wrote right back, and he was very excited. And so all of the drawings are Andy's. He's very gifted and creative, and a lot of the jokes are his. And I'll say that the book, it takes a certain approach to describing this stuff. Could have written like a dry, stuffy philosophical book about is physics universal or not, but instead it wanted to make it accessible and fun. And for me, that means like adding cartoons and dad jokes, because it gives your brain a break when you're thinking about these heavy things. And so the book takes itself seriously, like we talk about big issues, but it also tries not to be sort of stuffy. And so there's a lot of jokes in there, and all the drawings are Andy's. He's very gifted in that area.
yeah, I agree with your explanation of your book. Absolutely. Gabriel Goldberg asks, thoughts on on the film Contact? What are your thoughts?
Yeah, Contact. Loved it, right? I read that book many times. I love the movie, but it's sort of the fantasy scenario. It's sort of like we get a message and we figure out how to decode it, and it describes some technology we can build and dot 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 dot. And it's wonderful, but it's a little indulgent, right? I think it's fantastic, but it's unlikely to reflect reality. I think if we get a message from aliens, we're much more likely to spend 100 years trying to figure it out, or even wondering like if it is a message or not. Look, for example, at like the wow signal. Still, we don't know, is it a message? If is it not? Does it have any structure? How do we even know how to begin attacking it? To some alien, it might seem obvious. It might seem like, well, it describes itself. Of course, here's how you unpack it. But it's not so obvious to us. Or it could just be like a weird burp from a hydrogen cloud somewhere, or some weird instrumental thing. We don't know. We can't even distinguish between an alien message and some weird instrumental effect. So I love Contact, but I think it's deliciously optimistic.
Okay. So Jay Feldman asks, and this I like this because this Center for Inquiry does deal with conspiracy theories and paranormal activity and things like this. And Jay
Hmm.
asks, there's an oft used cliche that the arrival of aliens, even if clearly benign and non-threatening, would be so disruptive to humanity's sensibilities that governments must hide such an arrival and condition humanity until we are ready to accept the certain knowledge that we are neither alone nor the most advanced of beings. Do you buy into this cliche that the government should hide if it does indeed happen? I know some people think it's already being hidden, right?
Hmm. I've worked in the government. I'm very skeptical of the government's ability to hide anything for very long. Um, you know, this would require people being involved, and there's like humans with jobs and spouses and children and flaws, and it's very, very hard to keep secrets. How long did we keep secrets? The Manhattan Project a secret, and the technology there, right? Like a few years before that leaked out. And so the idea that there's some like deep secret and a whole like culture of physicists out there, being trained in secret, like where are these people getting their degrees from? It makes no sense to me, frankly. And I've seen it from the inside, and it seems like a very nice way to avoid having to provide evidence for the claim that aliens are here.
Okay. So I was thinking this too. John Murray asks, do you believe that aliens exist? I mean, there are credible individuals out there, supposedly. I'm not very familiar with this stuff, so I'm just reading the
Hmm.
question. Have professed personal experiences that confirm the existence of aliens. How do you feel about that? You're certainly in a position to ponder that question.
Yeah, it's a good question. I mean, do I think there are aliens in the universe? It's a philosophical question because I have no data. I want to believe it so badly that I'm convinced by arguments like life can't be rare and technology and intelligence will evolve. But I worry that I want it to be true, and so I'm being convinced by those arguments for that reason.
Right.
In terms of like the UAP videos and claims of visitation. And like, I would love if that were true. I would be number one person in line to believe that. I desperately want that to be true. But in order to be convinced of that, I need to be convinced. And so far, all we have are like blurry videos, most of which have prosaic explanations, or people telling stories, which they could be giving sincere accountings of their beliefs, but they could also be incorrect or wrong or misremembering or confused. So I think we're going to need something more than personal stories and fuzzy videos, at least to convince me. But
Yeah.
I'm a skeptic, but also I'm desperately want to believe. I'm not somebody
Right.
who's here to dismiss this as an impossible idea. I'm ready for it, but it's got to be real.
That's why I think the more you want to believe something, the more you have to your starting point must be to try to prove yourself wrong, you know.
Exactly.
So that's a good point. And here's a real physics question for you from Barry. In terms of physics, if the universe
Mm,
in which we live is
mhm.
undergoing what is essentially a gigantic explosion, why are time elements so consistent? For example, the rotation of the Earth, the time it takes to go around the sun, and so on.
Yeah, so the universe is expanding. I think an expansion is a better description than an explosion because it's not exploding from any one point. The universe is expanding everywhere. And so every part of the universe, you can think of it as space is growing. Every bit of space is making new bits of space. So everywhere we look, things are moving away from us because the universe is expanding everywhere. And that expansion is accelerating, which is amazing. But I'm not sure what you mean by time being consistent everywhere. Like the time it takes the Earth to spin is 24 hours, is doesn't reflect anything fundamental about the universe. And other planets have different spin times, and the time it takes to go around the sun doesn't reflect anything fundamental. And other planets and other solar systems have different times. So those periods wouldn't be meaningful, for example, to an alien species from another solar system.
And so, based on our current detection methods, what kind of alien technologies today would we be actually able to observe?
Hmm. Well, they would have, in terms of, I mean, if aliens just show up and they step out of a wormhole, boom, that's obvious.
Mm.
But in terms of distant aliens, the universe is vast, and if they send a message in every direction, like the strength of the messages that we've sent, for example, there was a broadcast from Arecibo, um, then we would not be able to receive it unless they were pretty close because the power of those messages goes like one over the distance squared, and distances are big and distances squared are even bigger. And so those messages would either have to be extraordinarily powerful or they would have to be directional. They would have to be pointed in our direction, like a laser beam or something. And that would mean that they would have to know we were here. And so that's certainly possible, but we haven't been broadcasting for very long in the history of the universe.
Right.
And so for them to know we're here is would be a stretch. To me, the most likely scenario is that somebody else has had the same idea we've had, which is let's explore the universe with self-replicating probes. because I think we're, maybe 100, 200 years away from the technology of being able to send out a few probes, which then land on planets, mine and remake themselves, and then you get exponential growth. If you do the calculation, you can explore the whole galaxy in like a few 100,000 years, which sounds like a long time,
Yeah.
but it's a tiny amount of time compared to the age of the galaxy of billions of years. And so, if we've had this idea and we're on the cusp of being able to do it, why haven't aliens had this idea and done it as well? Right? That's sort of the Fermi paradox. And my answer to that is like maybe aliens are just much more alien than we imagine. And it's not that they haven't had the idea, but like they don't care or they're not interested. Right? That maybe this notion of like going out there and meeting the rest of the galactic community is a human idea and not a broadly held one.
I have quite a few more questions here. What about the movie Arrival, where this is from Trey Petty, where language or whatever creates a space-time continuum
Hmm.
conundrum,
Hmm.
presumably to our advantage?
Yeah, so Arrival's a great movie, and I really like Ted Chiang. I have a few issues with the science of that movie because, the aliens there are supposed to exist outside of time, but then they still have back and forth conversations, and those require time. Um, the idea of like aliens having a different relationship with space and time is very attractive, and I think it's very cool to think outside of that box. I don't think that idea actually works when you come down to it and try to think about the physics of it. But I really do like the, Ted Chiang's idea of like, what if aliens have a different relationship with space and time?
Since this is from Amir Salehi, since our physics, and I'm sorry, my dog's enjoining in on the conversation behind me, and I do understand her
Wonderful.
language, although it's not human language. Since our physics is more cultural than we thought, wouldn't
Hmm.
it be more simple to use sound as the language based on their response reaction to the sound, a sort of custom-made language for that civilization?
Hmm.
Just straight
Well,
up sound.
straight up sound. Yeah, well, it certainly could be. And, when the aliens arrive, who knows what the best way is to communicate with them? That will be a really interesting moment, right? Like, do they even use sound? Does sound matter to them? Do they communicate by sense or by like weird colors on their skin? Or like even just figuring out the very basics of how to communicate with them will be a fascinating challenge. And I suspect that nothing we can imagine is really going to capture that. The boundaries of human imagination are tiny compared to what the universe has cooked up. Oh, you're muted.
The Drake equation,
Mm,
one of the parts is we have to be s- able to contact each other at the same point in time. And
yeah.
Reinhold Schleiper is asking, what's the probability of the matching of windows of opportunity for contact? I think that's what he's referring to. In other words, the two contacting cultures would have to develop on a parallel timeline.
Hmm.
What if they developed a million years ago or a million years into the future?
Yeah.
We may not have the right timing.
Yeah, we may not. On the other hand, we also don't know how long civilizations last. It could be that they last for billions of years, in which case it's awesome for us. We're fairly young, and then we get to meet these like really advanced, mature civilizations that have incredible science. Or maybe civilizations don't last for very long and they blow themselves up, and then we just really have to be lucky to line up. It's a big unanswered question. Most of the elements of the Drake equation are totally unknown with just this one example, and we're just guessing about the rest of it.
Interesting. Well, folks, we've gone over the hour. This is a wonderful topic, and I want to thank Daniel for joining us today. I know it expanded my mind. The universe is expanding, and our minds are expanding. I highly recommend the book. I had a great time reading it. Time for the holidays, so maybe people might consider giving this to their smart people in their families or people who like to think outside the box. Thank you all for joining us today. And I thank you, Daniel. I'm going to let you have the last word here.
All right. Well, thank you, everybody, for listening to this presentation and for expanding your minds about how aliens might think. And thank you very much to CFI and Skeptical Inquirer for hosting me. It was an honor and a pleasure.
Great fun. Thanks, everybody. Good night.